Hey, Michelle, how are you? Okay, we'll start in a minute. Hold on one second. Let me get my things for you. The lab updated now. Okay. Okay. So today we are going to work on our lab. One second. Let me get the document up for you here. It's not very long. Easy to. So while we wait, you can open your IDE. Don't forget that there's no class on Monday. We will not meet on Monday because of the holiday. So we will shift everything to Wednesday. We'll cover the lecture and do some hands-on stuff on Wednesday. I'm trying to, okay. Okay, so I'll add the video tonight for the lab. Do you have any questions regarding last time? Anything that you still need? Any questions? Okay. I also uploaded the note part 2, which covers classes, exceptions, and things. That was mainly the review for most of you who took 30A, but if you haven't, you can refer to the notes as well. Let me double check. I think we finished everything on Monday. Oh. Hello. Okay. All right, let's talk about, let me double check and make sure that we did everything. Okay, so on Monday, we covered some of the exercises. We talked about how to create containers, how to put together tuples and lists. I think we didn't finish the rest. So, and then we worked with some of the built-in methods to create our network list in Python script. So I think we finished number 6. Okay. And then we worked on using for range. This is Tony right here. With the protocol list. Okay, so just that's where I'm probably gonna pick up because I believe that that's where we left off from last time. So we were able to use a lot of the built-in methods to be able to create and modify our list. So for number 6, it touches on how to use range, and when you refer to the notes, part 1, it shows you an example on how to use the for range. So let me also get that up for you and show you where that's located. Okay. So after the list portion, it goes into range. And here it gives you an example on how to be able to do a search with the range using the list and then setting up the search key in the for range. And we simply just nest the if into a for loop and be able to look through all the elements in the container in order to find that. And we can use that as a template for number 6. We create a set of protocols, and then we set up a key to look for a certain protocol. And we also have a variable called found, and we would use a bool value as false. So for the for loop, we would have a for range. So for, right, the index, and we're going to go all the way to the end of the list. So we're going to go through every element of the list. And then if it it's going to look through each of the element in the index and find it to be equal to, if it's the same as the search key, then it's going to break and it's going to show. So this is where we left off last time, just to jog your memory. And that was number 6. Okay. Any question on this one? Okay, let's talk about the next one. For number 7, it asks you to also create a tuple. We want to display the content in the tuple, and we want to display the second item of that tuple. So let's look at 7. And I'm looking at the assignment that we did. So simply, we create a tuple, and then we use the parentheses. We added the protocols, and we simply use string to note each of the protocol. And you can use any protocol you want. So ideally, right, we would bring in a list of protocols after from the report. So you would import that in. But right now, we create a tuple, and we manually put in each of the string as each of the protocol. Then we have the protocols printed. So it's going to print the tuple, and recall the tuple, the content of the tuple you cannot update or change. Okay, so it's going to stay the same. Then I want to print the second protocol. So I'm going to use index 1 because the first one is index 0. So I'm going to go ahead and use index 1. So it's here, it's going to show me ICMP. And then we are going to print the last one. So that's going to be, we can use the negative index here, -1, or, you know, if you want to print the third one. So I think I touched on that one as well. Okay. So you can simply use an index to print an element at a certain position by using from left to right, we're going to use the positive index. From right to left, we're going to use the negative index value. So that was number 7. Any question on 7? When you nest just a bunch of else statement. Yes. So when you nest, all that is you would, like in this case, I would nest, right, the if inside the for loop here. So what that is that first, what it's going to execute the loop, and as it does that, right, if it goes through the loop and the condition is true, then it's going to go here and it's going to check the statement. So in this case, if it found my key, then that will be true. Then it's going to execute the body of that nested statement. So all nest is that it's could be a condition or a loop under another condition or a loop. Okay. Now this one is not nested, right? But the if here is nested. Okay. So we talked about 7 using indices, and we talked about how to use positive and negative index value for the position of your element. That's pretty easy. And then for question 8, I keep flipping to the lab here. This one is the dictionary. We have to make a dictionary for your user account, and that will consist of password, email, and department. We want to display the content of a dictionary. So a dictionary simply is, you're welcome, simply is a nested list, right? A multiple dimensional list. And dictionary uses key and value. So when you go to the notes, you can go to the section where it talks about a dictionary. Okay. So here in this example, you can name your dictionary anything you want, but in the dictionary, when you define it, it's a curly brace, right? And you would have the key in front, on the left side of the colon, and then the value on the right side of the colon. So this one only have, right, brand, that will be Ford, model, Mustang, year, 1964. So dictionary works really well with creating a record. Like for example, if I can make a dictionary of all my network devices, because the network devices has a lot of information, like the name of the device, IP address, put possibly some protocol or configuration or location, or specific things, or it could be for the user account, right? You have an account. Now, ideally, in a large scale, we would look at it as a database, where things are related or interrelated. We can set it up a relational table to be able to make those records related to one another. But in a small sense, in a smaller scale, we can use a dictionary. So some of the things that you need to know about the dictionary is, first, it needs to be ordered, right? So just like the other container, like the list, it is sequential. Also, like the list, it is changeable. And unlike the list, you cannot have a duplicate. So in a list, I can have all the items to be 100, okay? As long as and they would be throughout the container. And the index is different, right? So the value can be the same, but unlike the list, the dictionary, your items cannot be duplicate. I cannot have 2 brands with Ford. I cannot have 2 models, or I cannot have 2 years. So it has to be different. Your key must be unique. So I cannot have brand here and brand here again, right? I have to have different things. So it's going to use the key in order to correlate the key with the value or the data. But you can use any kind of data type. So here we are using string, but you can use int, you can use, I don't know, you can use string, like this one, you can use int, you can use float, you can use long, you can use any data type that you wish, as long as it's fulfill the purpose of that program. Okay. It is not a list. So a list contains a set of numbered values, while dictionary, it holds a pair of the values. So your key and your value always go together. You can use some of the commonly found method from lists in a dictionary, but there are some specific to the dictionary. For example, like the dot keys, that will give you, it will return the list of keys of the dictionary. Or you can use dot items, that will return the complete list of the elements in the dictionary. So if we want to look for all the elements in a dictionary, we simply use the dot items method or items method. And if we want to look for all the keys, right? What are the keys? Right here, brand, model, year. Then we would just use the keys method. So that's specific to dictionary compared to a list. Also, like all the other sequential container, we can also use a for loop. So when you write a for loop for the dictionary, unlike your list, you need to have two variables that's going to hold the key and the value. So we would say for ij, or for key value, or for kv in, right? And then that will be our dictionary name. And then we would use a method and what we want to execute for that, for each of the round in that loop. Okay, so let's play with this now. Okay. Okay, so for exercise 8, we are asked to first declare a dictionary of the user account. It needs to have username information, password information, email address, and the department. We want to then display the dictionary. After that, we are going to use an update method to add a job title or a role for that user. Then we are going to display the content after the update. We would then use length to return the number of key values in the dictionary. So basically it's going to look at, right, the pair, which is key and value of the dictionary, how many items basically. And then we're going to use the .keys method or keys method to list all the keys. Then we're going to use items to list the entire list of items in the dictionary. And we are going to implement a for loop. And so it is different than G or B. Because B simply print out the entire dictionary. On H, we have to loop through it. Okay, so here's my program. And you can create your user account however you think that will be fitting. So I have a dictionary called user ACC. And I would have a key called username. And I would have the value for that key, M Smith. Then I have another key called password. And then another, for the password, I would also use a string. So these are strings, right? Then I have another key called email. And then I would put in the user email information as a string. And notice that I'm using comma separated because they are comma separated values. Then department, I would have it under IT. So after we create the dictionary, let me comment this out real quick to test it so you can see the difference. After we create the simple dictionary, we're going to print the entire dictionary. So let's clear this. So here it gives me a dictionary, and I know it is a dictionary because it's a curly brace. So I have username, password, email, and department information accordingly. Now, the next step is we are to use the update method, which is a built-in method, to add in or modify the content of our dictionary. Okay, so we need to add the job title or the role for that user. So I simply have the next line where I would have user account, which is my dictionary name, and I would use the dot operator, and I would use the update method. Now, since I'm updating the dictionary, which has the key and the value, I have to make sure that in my parameter, I would use the dictionary format, which is the curly brace, and the key and the value accordingly. So I would have title and then the job. And you can put anything, right? It could be title and manager, for example. After I update, I want to print. So I simply reprint the dictionary to see that this is added. Okay. So as you can see, when we issue the update, this was added and it is successful. So I want to take this opportunity to show you how you can use dictionary, even though some of you already learned this in 30A, right? I've seen a lot of my students when they turn in their project, they love using lists. They're afraid to use anything else because I think a lot of the students are trained on arrays and, you know, just having to use only array. Python is a little bit more fluid in how we can implement container. So dictionary is a good option, especially when you have content that would require a key and a value, which is what we see a lot in IT, right? Okay. Then the next step is going to require us to use length. And we are going to simply use length with the dictionary name, and I pass it into, right, a print method just to save me one line. You can write it in 2 lines, of course. And so as we see here, right, we do have now, after we do the update, is 5. So this is a good way to really track to see if you add, things to your report or, at least the container here in the dictionary. So this method automatically, it's a built-in method, of course, it does iterate. So it is an iterative method through the content. It's going to look for the items inside your dictionary. So we do have 5 after the update. Any question? Okay, so now we're going to use the keys method. And I comment out the rest so that way you don't get confused. So again, we do the same thing with the keys method compared to the length that we just did. So I simply do a print statement and then I add the dictionary name dot operators used here and then keys method and then enclose that for the print method. So let's run this. And as you can see, we have the dictionary keys. It lists all the keys, right? The things that I have added to the left here of my dictionary. So this allows us to find things quickly in the dictionary by using the built-in method like keys or items. Then after that, we are going to work on our items. So again, we are going to use the print method and then put the dictionary name with the dot operator and the items method there. So now you would have the dictionary items. So it would list everything that would be on the right of your dictionary keys. I'm sorry, it lists each of the items. So what it did was, if you look at how the structure of this would be, that it treats the key and the pair value as a tuple nested into a list, okay, as a set of data when it returns those items. That is, okay. So it allows you to see the grouping of individual key and value in a group. Then lastly, we are going to use the for loop, and we are going to loop it through our dictionary, and we are going to display key and value. Okay, and I'm going to show you how it's different to the first step that we print. Okay, so when you do it this way, it's going to print it on each of the line, even though it's still going to be the same content. So username, password, it drops it into each of the line when you loop, right? Because as it loops through, it's going to show you piece by piece, compared to when you are doing just a print for the entire dictionary, it's going to print it in one shot. Okay. So there you can see the difference in how it outputs it. So as we loop through, it's going to do that first round, second round, third, and so on until it gets to the end. So we simply have a for, and here I use key and value as variable. You can definitely do ij or kv or whatever variable you want to use there. In, we're using a membership operator, and then our dictionary, and then we just simply want to print out, right, the key and the value as it loops through. Simple enough. Any question? Okay, so that took care of number 8. I do want to wrap up the assignment, and then that's why I only add like a few questions for the lab, so we can at least target both this week. So let's, and I will post this video tonight when I get home. So it should be up by like 10 or 11 at the latest. Okay. Let me open up 9. 9 is very easy as well. So now we're going to move into functions, and functions, we can use function to really break down the task in the program. We can definitely incorporate methods or functions in classes and be able to, it really streamlined the process in that you can define a function once and be able to really use it multiple times as long as you call it in the main or at the bottom. So for 9, we are to define a function, and we need to use arguments with our function. We want to be able to display a list of your network servers. And we're simply going to do a screenshot after we successfully run our program. So it's really easy. So we would first using the def keyword to define a function. So we do def, and then you can name your function anything you want. So in this case, we customize our function. So I just said show server. and I'm required to use an argument. So I have systems. And in my function, I'm using a for loop. So I would say for s in systems, print s. And this looks like protocol to you, but they are services on server system, right? So I can have an FTP server, a DHCP server, a remote access server, an Active Directory role on the server, IIS role on the server, Apache, DNS, and so on. So after I have my for loop, so simply it's going to loop through and it's going to see, right? It's going to print each of the server role. Then I define my list of server. You can have more or less. And then here is the call. So when you call, you simply use the name of the function or the method. And then your parameter, you have to pass server list because we declare that here. Okay, that was defined, initialized there. So when we run this, we would have a list of our servers. Okay. Sure, we can print out the list itself, but in this case, we want to use a function or a method that does that use a loop to be able to go through that list one by one, gonna print each from that list. Okay, so with this exercise, we learned how to define a function and use that function to implement a loop to print through, to access a container, each element of the container, and display the element. Any question? So in the notes part 1, I have a section on function. There's also example that you can see there. And it talks about how, so far what we've done with 9 is we are doing a user-defined function. There are built-in methods or functions that you've seen. We've been using it up until number 8. You can also have a lambda function. This allows you to create what's called the anonymous function. So we would use the lambda keyword and we can add in different parameters. So when you look at some programs, sometime Python program, you will see lambda function. Okay. And then you can also implement arguments like what we've seen in exam or exercise 9. So here it shows you how you can display, right, certain things, and you can use this example like what I've done for 9. I just implemented this. And that's how you would use a list as arguments. Any question? Okay, but I'm not sure. For hash structure, I'm not sure what you mean. So dictionary, all that is just gonna be just a larger container that will be in your memory. And instead of having one item like what you've seen on the list, it just have two, a pair, right? It's always gonna associate a pair each time. Maybe I'm not sure what you mean by hash, but okay. Yeah, so it's okay. I'll look into it and see, how that will be. Maybe they're referring to something that will be on RAM. Um, but good question. I'll look into it. I don't, yeah. Maybe they're referring to certain specific things about the dictionary. Okay. Other questions? Okay, you already know how to do 9. So that would wrap up our assignment for this week. And then now we're gonna hit the lab, which gives us about we still have time. So an hour and a half. We should have plenty of time to do the rest. All right. So let's touch on part 2. So in this part, I wanted to address class exception handling, which unlike 30A, I don't go in depth with a lot of these topics. It's really aimed to give you the basic or the review. And then in the case if you need to use it, okay? I definitely recommend for those of you who want to expand your knowledge a little further, you can use Python documentation. And there are a lot of really great, wonderful resources online that are free. So you can definitely do some practice with, dictionary, list, tuple, for loop, all of that, okay? So we're trying to squeeze all of the entire class into 2 sessions, so it's going to be a little limited. A function is good to use for data management, right? Instead of referring to, yes, that is correct. So the reason why we want to chunk it, right? We want to make it like a function is that we can control the function. And we also now going to get into class, so that way we can take it a little bit further and really implement object-oriented design to our program. So a class, you can have it user defined, where we would have a set of attributes that we can utilize for that class. So what are some of the attributes? That could be variables, that will be class variable or instance variable, or it could be functions / methods, right? It could be methods. And we simply use the dot operator to be able to access those attributes, variables, and methods. The class can also have documentation string, and that is accessed via your class name doc. So under the class, we can declare variables. We can also have, so each of the class variable or instance variable, they can hold data because they are container. Welcome. Then we can also define functions under the class, and we can use the function in a way where we can overload the function. That means that the assignment of more than one behavior in a particular function, so we can change, right, the way that the data is used that way, that by implementing overloading. We can also have it where it would use it for by types or of the objects or the arguments that we pass. Now, an instance variable is defined inside a method, and it belongs only to the current instance class. Compared to a class variable, it can exist outside of the method. It's like how before when you're defining a function, there's some variable inside the function compared to variable that's above that function that could be global, right? So that brings us back to what would be an instance. An instance is an object of a certain class. And Java, and I'm sorry, not Java, but Python does use object keyword as object by default. So in base with the built-in library, you can use object and pass it as object. You can look further into that. Now, the reason why we implement classes, we want to be able to have inheritance. So you can have many classes, and we're going to play with at least 2 classes. And we want to be able to have ways to utilize, right? We would access attributes from one to the other or control how those attributes are accessed. So what do I mean by that? I can have a class accessing the variable of another class or a function of another class by inheritance. So when you want to make an instance or an object in a class, you instantiate that class. Okay. And we can implement, so these keywords, I wanted to highlight them to make sure, because this is always an obscure area for a lot of the students. They can understand the basic principles, but then when it gets to class, it tends to be really difficult for students to understand inheritance. And if you can't understand the basic structure of a class, then it will be harder to understand how that class is used. So the example that you see below, and you would see that it would have a class called employee. And here we would have a variable called emp count, and we would have it as 0. Now to really to have a constructor, you need to use the init method, okay, to instantiate. So here I call it init, but it's initialization, right? So you would define the constructor here, and under that we would then create, right? We would have the instance variable, name, salary. And since this is part of the employee class and we want to access that member variable, you simply would refer to the class dot the variable name. And we want to update it one by one, right? Increment. So after we have the constructor, we would then go into defining the methods. And simply you can have the methods or the function to do anything. So the member methods, you would give it a name, and for the parameter, we would use self. And keep in mind that this is just like a placeholder. By practice, we would use self, but you can use any identifier that's unique. And we want to print out. So as it goes, it's going to count up how many employees, and it's going to print that out for me. Then next, we are going to display the actual employee information. So we have another method, and this one is going to access, right, the name and the salary. So it's going to give you the employee name and how much they make. Now we're not done. So we have attributes set up for this class, right? But now we have to have objects in order to access those attributes. So here we are going to create the instance called employee by calling the employee. So when you make the object here emp1, right, you're going to bring down the class, and then whatever the arguments that you want to pass. So it could be string value. So in this case, I have to use a string for the employee name and how much the income is salary. So I have one object for each of the employee. And then once I have the object declared or the instance declared, I simply use that to access the methods from that class. So emp1 dot, and then here's the function. That's how you call, right? If it belongs to the class. Then we are going to print. And sorry, I cut off the last parentheses there. So here's the class example. Okay, and then we will print. So I use a little bit different data. So you got Lisa, right? $2,000, Richard, $5,000. And it gives me the total count for the employee. So now you have the breakdown of the class. It's jog your memory from the prior class, or at least show you how you can create a class. Let's do the lab. So in lab 1, it asks you to, the first exercise, it asks you to create a script that would display network device information. So, I do this a lot because it's the easiest that we can correlate IT, but down the line, we will do more with our Python script, of course, not just to display information. But we want to make sure we display, at least the device name, IP address. So the program should define a class and instantiate objects to access the attributes of that class. The class should consist of member variables, constructor, member methods, and objects. We want to test the program with at least 2 of the devices or 2 arguments. Okay, so you can use the example that I provided in there, or you can create your own. But let me open up lab. So I formatted the way I structured this is pretty close to what you've seen in the example. Okay, so I have a class called devices. And then I have the def count as 0. So it's going to count the device. I have the constructor very close to the example. And I'm going to have the name and IP address along with self in the parameter. So now we would have self.name is name and self IP address is IP address. And just like the other one, since my class is device, I would do device def count. And I want to increment that. Okay, so it's going to count up my device and it's going to give me the information. Then I also have 2 functions or methods. One is going to display the count itself, just like the other program. The second is going to display the name and the IP address of the device. Then we are going to create one instance, which is def1. And this instance is part of the devices class, so it's to instantiate that class. And we want to make sure that our arguments is enclosed. So I would have Cisco router and the IP address. So that's going to get plugged into what we have previously added here. The second instance is going to be my dev2. And in this one is also part of the devices class. And then I have a different argument used there. So Netgear switch and then a different IP address. And they're both in as used as strings. So once I instantiate the objects, I would then use it to access, right, the method that I have declared. So def1 display def, def2 display def, and then lastly, I wanted to print out how many devices total I would have. So I run this. And there we go. So it's very close to what you've seen in the example. Any questions? So this is using one class, right? And we simply look at all the pieces in that class and making sure that, you know, we have a constructor, we have instance, we have variables, right? Methods. And this takes practice. It's, you know, something that you would need to, but Python is very flexible, right? You can have a class without a constructor. I want to show you that to you next for the next one. You can also, but you know, the same thing. The concept is that when you declare a class, the purpose of that is to really use, right, to instantiate your object and use your object to access the attributes. That's what object-oriented design, it really means. Why am I showing you this? Because you might not have to create script that have classes all the time. But when you're using packages or modules, you will likely see classes being implemented because most of the libraries, right? Most of the libraries are written by developers that came from their object-oriented uh, uh, developers, or some of the libraries would use compiler, right? So you often see that there will be class structure in those type of programs. Any questions? All right. So we go with this one. Let me close this. Okay, so that was number one. We only have to do a few today, so. And you don't have to add all the comments, okay? That was, you can take out all the comments. For number two, we are going to write a Python script that uses class inheritance. So that means that we have to have two or more classes, okay, to display device information such as name, IP address, and location. The program should fulfill the listed requirements. It should contain a parent and a child class. So there are only two. Hold on. So an instant method are member functions, and member functions are called init. Yeah, so no, init methods are, so when you define init, let's go back. when you define init here, you are making a constructor, okay? But the member methods, there are functions of that class. This is also a method of that class, but this method is in charge of making a constructor. So when you define init, it is it is a constructor of that class. These are the member methods here, okay? Yeah, so when you create a constructor, you are making a blueprint of that class. That is correct. So when you create a constructor, all you doing is you're going to create a blueprint of that class, which consists of variables, right? Containers, sometimes it could be a list, right? Or methods or methods, okay? So is that clear? So can you have a class without having this section right here? You sure can. Okay. Sorry, my battery. Let me put my charger in because I just came from another class right before your class. Okay. Then for number 2, we were saying that for number 2, we want to use 2 classes, a parent and a child. And then the child class should inherit the parent class. And once you do 2, you're able to implement more, right? You can have 1 class inherited from 2 classes and so on. So we can also use super. Yes, you can have many functions in a class. And so for example, you can have a parent class, you can have many functions, and then you can use that function in the child class if it's properly inherited. Okay. So we want to inherit variables and methods or functions from the parent class. Okay. I want to make sure. All right. So what we would do here is first, we would then have a class called, I have a class called def. This is the parent. Okay. And you can name your class anything you want when you write this. I use the constructor for this one. So you can definitely do away with the constructor. And instead of using self name, you can say name is, and you can declare your variable and so on. Okay. And then I will show you an example of that from my 30A class. You can definitely have multi-classes without having this. But here I have a constructor, and since I'm displaying name and IP address, so I would have that in the parameter there. So it's just like the one before, self.name is name, self.IP address is IP address. And then we want to print device name and IP address here. The second class I have is LOC, stand for location. And this is a subclass of def, which is the parent. Okay. Now for the instantiate, to construct this, right, I have the init, and I would have self name, IP address, location. And it's going to access the superclass. and then I want to print out the location. So the important takeaway with this is this object, that the instance that I create here, it is really a child instance. It's part of the child class, the subclass. But as I pass the parameter, it's going to plug that into name, IP address from the parent. So you can access variable, not necessarily method. You can just use the variable this way and be able to plug that into and update that from the child. Okay. And as you can see, this is here. Okay. And HQ is something that I plug in, but the location is part of the subclass. The IP address and the device name is part of the parent class. So when you create a child object or instance, you can have it, you would then instantiate it for this class, which is the child class. That will make it a child object. And this object you can access, right, its class and the parent class if you carry it down properly. Okay. Yeah, in some IDE, it fills it out for you. Because, you know, they already have it set up. I'm using Tawny, so you just have to do that yourself. But yeah, you can definitely use IDE that pre-fill out some section of the code for you. Like for Java class, there's like two lines to really print. So it pre-fill out the main and the art stuff for the students. And it also highlight things in color and give you the debugging output that, you know, to help you out. So it's good. Okay, so in the notes, it gives you some example on how to use it. Let me see if I can find my 30A, and I think that was week 10. Show you one that doesn't have. So this one doesn't have any kind of constructor. Okay, so you can still create classes without having a constructor, but you know, by practice, we want to make sure that we have some kind of constructor, at least in one of the classes. Okay, so you can have one in the parent class and then, you know, not in the other, or you can skip the constructor. Okay, and you can still have, so I define a method here, and you know, I'm still able to access the method for inheritance. Okay, so this is using, you know, that's overriding method for classes. You can have it inheriting from both class, right, by just using a comma and then list the parent class. So class 4 here is a child of 2 and 3, where class 3 here is the child of class 1, and class 2 here is the child of class 1. So both of these are children of 1, and then class 4 is a child of 2 and 3. Okay. So you do see that there are example programs that don't use constructor, but I encourage you to use constructor so that way you can understand the concept and the design of OOP a little better. Okay, how it's blueprinting and so that is number 2. Question. All right. So, okay, I see some chat. You're welcome. Okay. Yeah, no problem. Next exercise, it's gonna be on exception handling. And in the notes, I just simply pull some stuff from 30A and give that to you. So let's take a look at that. Okay. This is part 1. Move it to part 2. So for exception handling, this is a way that we can track or prevent certain error from stopping our program. We can also look at, so we always should expect that there might be some error that could be happening, whether it's caused by user input, computation, etc. And when you're working with input and output, like using IO library, you just got to be mindful that there could be events or occurrences that will cause your program to halt, in that it would run into error, even though you have it automated. Okay. Then we would then think about how we would utilize uh, the feature in Python to really handle exception. In the case where we would have statement like finally, assert, or raise, you also see try and except statement where we would be able to attempt, right, a certain condition, and otherwise it would handle something else. Okay, so we can apply certain condition with exceptions. So there's some example there for you to look at, right? So here, when you're looking at try and except, your try statement, we can have it do something, and then if it does it fine, then that's okay. It's going to skip this part or this or this, right? But if it's unable to do that and it's run into error, and you have to specify like the type of error, could be value error. So we should always expect some form of error, right? If you're using built-in method, it will tell you like if this function doesn't run, it's going to generate like this type of error. Okay. Then we can have value error or type error or certain type of error. So you have to specify what kind of error that is and what it needs to do to handle that error. Okay. And a form of error could be runtime error. Okay, so in the case when we divide it by 0, that will cause a runtime error. Then we can also handle that. Because if you don't, sometimes program will stop, right? The application will stop and nothing will happen. So we should always expect some form of error for the system and be able to handle that. Okay. Okay. So in the lab, it asks you to know number 3. We are going to write a Python script that's going to ask the user to enter their name and password. We are going to use exception handling to validate the username, right? As alphabet or password as alphanumeric. And I try to make it more relevant to your field, right? IT, cybersecurity. But you can do exception handling in so many different ways. And we can also implement if else statement with this one instead of exception handling. So for the lab, it's simply just a few lines. We can say try, okay? And we're gonna ask for the user to input their name. So we would have a variable called name. And that variable is gonna contain the input of the user. And inside the input method, we can simply tell them, enter your name, your username. And the next part, we are going to use the assert statement. And this is going to check to see if this condition is met. Okay, so we are using an is alpha method. And this is going to check to see if their input is alphabet. So if I'm trying to put in something that's not alphabet, like numbers, it's going to tell me no, assuming that we have the user accounts username as only alphabet. Okay, in that case. So if it meets this condition, then it's going to go here and here to the else statement and finally. If it doesn't meet this condition, it's going to raise the value error and it's going to tell the user that they did not enter the correct name. Now I didn't, so we can do a second step. I'm just going to use this to do the next part. Password, right? And then we can use it to check alnum. Okay, so I simply duplicate that for the password part, but the method I use for built-in is alphanumeric, which allows us to use number and letters. So that way I can use password 1 and it will take it. Now let's test this again and then try it with numbers. Right. So it now raises the error, as you can see. So it stops this program, right? And then it tells me the message here, you did not enter the correct password. So when you do a raise statement, it's going to refer to this type of error and it's going to generate this, it's going to output this text that you put into the argument, the parameter here. Okay. Let me clear this so you can see more. So let's run it again. So let's say if we put in the username correctly, and then the password we just use password without the number, it's still going to take it because password is still an alphabet, right? And when you're using alnum, it's going to take letters and or letter only or letter and numbers. Okay. Any question? So this is how we can use right? Exception handling statements to handle. And like I said, you have to really think about or determine the type of value that it might come across. Okay. Finally is always it's always gonna print. Right? I forgot to change this. To make it a little better. Any question? Yep. Yeah, you can handle exception by using try and except. Right. So if you expect something that could be occurring as an error, then you would implement try and except. Um, so there are different ways that you can use it. So the assert is it's going to allow you to test the condition like the if condition. Okay. But the raise, if you using the raise, you can actually cause, right? You can simply use the raise statement, but the exception is raised when the errors occur at the runtime. You can manually raise it, or you can have it checked based on what could occur. So if you're expecting an error and you can handle the error that way. Okay, so here we can say, try this. Okay. If this is true, then it's going to go to here. If it's not, it's going to jump here. Okay, questions? So screenshot your code for the 1, 2, and 3. And then I only require things for modules and packages because spending also including how to write modules or packages sometime. So basically module is another Python file and I can incorporate that to my existing file by doing an import statement. Okay. So let's say that I'm writing this program and I want to add another program to it instead of repeating the other program, and I can save some time by doing import. So I want to use this opportunity to let you think about what kind of things that you want to explore in this class for cybersecurity. There are modules and packages that already been written. It's also stated that in your syllabus. Okay. You are probably have seen or heard of Python files that you wanted to use, such as nmap. When we are looking for a huge amount of data, if someone did not add any feature to manage exceptions, How can we approach this problem as a programmer? Will that ever happen? So if you have a large like input data, so if someone entered the data and if you have to handle the data, you would probably have to look at how you can break that data down to smaller pieces. But in the case where if you're referring to file size, you can handle the exception like in the case where if you don't want people to upload data too large or you know transfer a lot of data as it comes across like through a email and so on, so you can handle it with exceptions, right? If it's large or if it's too large for your system to handle, then you can implement the exception handling process with that. So let's think about that, right? Like when the user is uploading a file that's over a certain limit, we can also use exception handling to control that, along with if the data is exists and if it's too large for us to store overall, right? Like transferring data and so on, or we want to prevent malware from certain point where it could be embedded and make the files larger, then we can handle the exception that way as well. Okay. Or in the case where if our application sometime would run into error when the file is very large, then we can implement exception handling to handle that error that could possibly happen. And that would stop everybody from using the application. So in the case for large data, you can use exception handling in many ways. Okay. So if it's not implemented, then that might be an upgraded feature that you can add to that existing program. So we would say, okay, we can add a module and be able to implement that module into that existing application, and you simply would see how that module can work forward. So when you see updates and things that change on the application, it's not necessarily that they have to scrap down the whole entire program to be able to modify everything. It's about adding elements in there that will work with the existing program. And module in a package is perfect for that. You simply add a second or a third Python file that will work with your existing, right, class, variables, functions, and so on. Any question? All right, so the last thing that we need to do before we end the session is I want you to find, right, a package or even a file. Most of the time, you're going to find the package that you would consider using for this class. Okay. In the content of the syllabus, you will find that it listed some of the things. And so I want to take this opportunity to let you think about how you would be able to implement like PyMist and map, PyFish, even async IO, we mentioned that earlier before, and so on. So if something really interests you and you've seen it, like if you have done a keylogger program or you've seen that done and it's using a certain library or module or library package, right? So you can also add that. So for example, if I want to implement threading, I can have threading or thread, right? Async IO, we talked about that before, and so on. So if you want to research, you can also Google that. Okay. So here I have a couple of things. So here's the IO, and you've seen this. So this is for text IO. It's also used for like input from keyboard and things like that. And then also you can use PyInput, right? So if you wanted to use image processing, that will be fish or PyFish. And then if you wanted to look for a Python package, let's say for security. And here you probably have to find, you got to dive a little bit more. Okay. Here's some information about safety. So there are a lot of different types of packages and modules that you can use and be able to, you know, so when you work with with these type of files that are provided by open source developers, you should always take a look at their documentation before implementation, right? Like for example, this one, it talks about how you can use it to stream file. If you're writing multi-threading, how you can do file IO, and so on, okay? And then if you wanted to use like async IO, so you can go to their documentation and then it tells you what that would be, how to use it. And then if you want to implement it with high or low level API. So documentation is a good thing to start, but look at how it's written, right? We can have it import, or you can say from async IO import a module. So a package would be a group of, right, various files that would be utilized for a certain purpose. And we would call that, consider that a library. But in this one, if you import the whole thing, you can, or you can import an element of that package by doing a from statement. We would say from async IO import blank, right? Whatever that you want to bring in. You can also bring in a class. You can also bring in a method from that class if you don't. Now, the more you bring in, the more storage it's going to take, right? So we want to be mindful of how we're using the resources in our program to make sure that it's light and it's not incumbent with a lot of like additional storage for other things. Okay. So for the last one, I just want you to focus on finding something that will be suitable, that would interest you. You can provide me with a brief description of what that package or module would be. And they are different, right? Or if you want to mention a little bit the purpose of it, how it should be used, that would be cool too. Okay, any questions? And we will have plenty of practice doing import statement and using modules and downloading and install. So when you're using packages, keep in mind that the IDE that you're using, make sure that it sees your package that you're using, right? Most of you took my 30A, you're familiar with TK Enter. Some students that didn't work for them because they didn't have it incorporated in their IDE. They did download and install it, but they didn't have it. So the IDE didn't see it, so it's not able to pull the file from that downloaded package, okay? And so you would go for Tawny or most IDE, we can go to the options or the tools, and then you can add in the plugins. If you're using plugins or if you're using packages, you go to see how manage packages here, and you can find the packages. So async IO is here. I installed that a while back. So you need to install it and have it visible to your IDE in order to use it. And I know Visual Studio requires that. All IDE requires that. Okay. Even when you run it on command line, you still have to download and install it. Okay. Any question? Okay. So don't forget Monday, no school. If you have class on Friday, we also observe holiday on Friday. There's rarely any class on Friday anyway. But no school on Friday and Monday. So there's a long weekend. I hope that you enjoy your weekend. Stay safe. And if you have any questions, let me know. Okay. So I'm going to pause the recording. I'll stick around for questions. We finish.